So this is a pretty straightforward question on circular motion. It is given two particles A and B moving in a circular path, concentric circles of radii RA and RB with speeds given VA and VB. Their time periods of rotation are the same. We have to figure out the ratio of the angular speed. First of all, understand that the speeds which they have given VA and VB, those are linear speeds. And we have to figure out the ratio of the angular speeds. Angular speed we know is omega. Hence, the ratio which we want to find is omega A divided by omega B. So, how do we proceed? In the question, it is mentioned that the time period of rotation is the same. So, what indeed is the formula for time period of rotation? If we use the most basic formula for time, which is distance upon speed. Now, consider an object moving in a circle. So, what is the total length of the circular path, which is circumference? That is 2 pi r. So, we will write down distance is 2 pi r divided by the speed. Speed will be linear speed in this case, which can also be written as if an object completes one full circle. So, what is the total angle which the object travels? It is 360 degrees, which is 2 pi radians. So, in the numerator, we will write 2 pi. That's the angle in radians, and we will divide that by the angular speed omega. Hence, we know that the formula for time period is equal to 2 pi divided by omega. Now, in this question, it is clearly mentioned that the time periods of both objects A and B are the same. Hence, let us write t is the same. Now, which means from this formula, t is equal to 2 pi by omega. Since time period is the same, omega will be the same for both objects. Hence, I can write omega A is equal to omega B. Hence, the ratio which we want to find, omega A divided by omega B, that will come out as 1:1. And hence, answer is option A. All right, although the question is done, I am going to present one more approach which some students like to follow in this case. Let's see what is that alternate approach and is it even that effective? So the speeds which were given to us was VA and VB. Those are linear speeds and we have to figure out the ratio of the angular speed. So some students use that formula which connects the linear speed with the angular speed and the formula goes like this: V is equal to R omega. Hence for object A, we can write VA is equal to RA into omega A. Similarly, we can write VB, which is equal to RB into omega B. So these are the two equations. Now, since we have to find omega A divided by omega B, let us divide these two equations. Hence, we can write VA divided by VB on the left hand side. This will be equal to RA divided by RB, and then we write omega A by omega B in another bracket. Now, omega A by omega B, this is what we are supposed to find. So let's make this bracket as the subject. So all we need to do, we just cross multiply and let's make omega A divided by omega B as the subject. So we will get a VA into RB divided by VB into RA. So all we have done is just cross multiplied so that we make omega A by omega B as the subject, which means this should be the answer. And this is where students get stuck. Now, although the approach is absolutely perfect, but if you look at the options, none of these options matches this. Hence, you should deduce that whatever you have found out is indeed true, but we need something which is matching the options. And that is why we use the time formula. Time period is 2 pi divided by omega so that we get the ratio as 1:1, which was option A. So, in an exam scenario, if you are using a particular approach to solve a question and you are unable to get what is there in the options, please switch to another approach so that we get the required answer. In this question, two blocks are mentioned, A and B, masses 3m and m respectively, and the entire thing is connected with one string and one spring. So the spring is connected to A directly, and A and B are connected with a string. Now the question is asking, once we cut this string, what will be the accelerations of A and B? So how do we approach this question? Step one is to always draw the free body diagram. We just need to figure out what are the different forces acting on the system before the string is cut and after the string is cut. So let's do the before case first. So let me write here before the string is cut. So let us draw the individual free body diagrams of A and B starting with B. So let me draw B on the right hand side. So the first force acting on B will be the weight of the object B, which is mg downwards, and there will be tension going in the upward direction since the string is connected. Now, if we focus on A, what are the different forces acting on A? So the first force will be the weight of object A, which will be 3 mg, since the mass of A is 3m. Then A is also connected to the string, so it will have T tension going downwards. Please remember the direction of tension is always away from the object. That is why for object B, the direction of tension is going upwards away from B. And similarly for object A, the direction of tension is downwards because T needs to go away from A. Apart from T and 3 mg, is there any other force acting on A? Yes, it is, and that is the spring force. If you analyze the system carefully, because of A and B's weight, the total weight is 4 mg. Now, because of this weight, this entire spring is going to get elongated. And whenever springs get elongated, they have a tendency to pull the objects. So, on object A, we will draw a spring force. So the upward pulling spring force will act on A. So the spring will apply an upward force on A. So let's draw that. On A, we will go upwards. This will be the spring force. It's a pulling force since the spring has been elongated. So these are the force diagrams before the string is cut. Now all we need to do is just balance the forces. So for object B, we will write the value of T will be equal to mg, since the upward and downward forces need to cancel each other out. Similarly, for A, the upward force is Fs, which is the spring force, and the total downward force will be T plus 3 mg. Now, since the value of T is mg, we will put mg over here. So, the value of the spring force will come out as mg plus 3 mg. So eventually, let us write the spring force will come out as 4 mg. So this is the magnitude of the spring force which is acting on A. All right, so this was the analysis before the string is cut. Now let us say if we detach this particular string, so we cut the string, what will be the different force diagrams now? So let's write. Afterwards, let's focus on B first. Now we know the obvious force acting on B is the weight of object B, which is mg downwards. In this situation, once the string has been cut, there will be no tension acting on B. So there will be no upward force acting on B. Hence, we can say the only force which is acting on B is mg. So for B, let us write the net force acting on B will be mg. And how do we find the acceleration? Acceleration is figured out by the Newton's second law. F net is equal to m into A. F net for B is mg, and if we divide by the mass of the object, we will get the answer as g. So acceleration for object B should be A. And let's see, if I go back to the options, acceleration for B being g is only there in option B and C. Hence, A and D can be discarded. Now let us repeat the process for A after the string is cut. So let us draw the diagram for A. The first force acting on A is the weight of A, which will be 3 mg. Again, like B, there is no tension connected to A because the string has been cut. There will be no downward tension acting on A in this situation. But the spring is still connected to A. So the upward pulling force of Fs, which was 4 mg, is still acting in this case. So let us draw on A. We will draw an upward spring force whose value is equal to 4 mg. Now, like B, we have to figure out what is the net force acting on A. So we have a 4 mg going upwards and 3 mg going downwards. So since they are in opposite direction, we will subtract. So the net force which is acting on A will be 4 mg minus 3 mg, which comes out as mg. So we can say that the net force acting on A is mg, which incidentally is the same as the net force on B as well. But will the acceleration of A be the same as B? Let's check. So let us write down the formula. Acceleration for A will be equal to the net force acting on A divided by m. Now the net force acting on A is mg. But what is the mass of A? If you go back to the question, mass of A is 3m. So instead of m, which is the mass, we will write 3m in the denominator. And then we just simplify it, we will get g by 3. Hence, acceleration of A is g by 3 and acceleration of B is g. Let's see which option has this. G by 3 and G, that is option B is the answer. And that is how we solve questions like this. Step number one is to draw the free body diagram, but we need to draw the force diagrams before the string is cut and after the string is cut. And then we just use the Newton's second law, F is equal to ma, to figure out the individual accelerations.